Welcome to clickmyproject.com. Let's discuss on the paper Adaptive Sequential Prediction of Multidimensional Signals with Applications to Lossless Image Coding. In this paper, we are going to analyze the problem of designing adaptive sequential linear predictors for the class of piecewise autoregressive multidimensional signals and adapt an approach of minimum description length to determine the order of the predictor and the support on which the predictor operates. The predictor design problem is particularly interesting and challenging for multidimensional signals such as images and videos because of the increased degree of freedom in choosing the predictor support. MDL is a technique from algorithmic information theory which dictates that the best hypothesis for a given set of data is the one that leads to the largest compression of the data, and we seek to minimize the sum of the length in bits of an effective description of the model and the length in bits of an effective description of the data when encoded with help of the model. Thus, our proposed MDL-based adaptive predictor is applied to lossless image coding. Now let us see the explanation of this data flow diagram. The first block is loading the input image. We are going to consider the grayscale image. Come to the second one, mapping and sequentializing. The given input image is in the form of matrix. The 2D matrix consisting of m cross n pixels is now converted into a sequence starting from x1, x2, then up to x m into n. Come to the third block, it is context modeling. It is a divide and conquer method based on separation of sequence into subsequences by context so that each subsequence can be approximated with a piecewise autoregressive model. Now the next one is estimation of correlation. Now here we are going to use correlation instead of Euclidean distance between xi minus t and xi to sequentialize past samples to form spatially nested predictor supports for different orders of the PAR model. The samples are sequentialized with correlation coefficients rather than Euclidean distance. Come to the next one, it is generation of 2D support. Given the spatial configuration of the 2D predictor support, the K predictor parameters can be computed here. Following this, the computation of piecewise autoregressive coefficients is proceeded here. We introduce a technique to choose a causal training set of past samples and associated support samples. The next one is prediction. The residual entropy can be computed by calculating the variance of the prediction errors for the samples. Now at the final, we are able to get the compressed image. Now we are going to evaluate our proposed implementation system performance by computing the two parameters. The one is compression ratio and another one is bits per pixel. Let us see the demo for our proposed implementation. This is the main file context main.m. Select this file, right click, select the option run file. GUI window will be shown to you. Under this, press the button browse input. File dialog window will be shown to you. Under the images folder, select any one image. Now I am going to select the second image and then press open. It will be displayed in the first access control. Following this, press the button pre-processing. The filtered image is displayed nearer to the original image. Then press the button PAR model, piecewise autoregressive model. It is displayed the next to filtered image. Afterwards, press the button compress. Now it will take some time to display the predictive encoding result. The result of execution of this compress button is displayed here, the predictive encoded output. Then following this, press the button reconstruct. The predictive decoding and the reconstructed image is also displayed here. The interstage results are nothing but the first one is image obtained after subband coding and the second one is image that is taken after inverse integer wavelet transform. Now press the button Analysis. Now the compression ratio calculated is displayed here 10.1922 and the bits per pixel is computed as 0.784912. The residual image display here shown to you is nothing but the difference between the reconstructed image and the original image, that is before compression. After viewing all the results, we can say that our performance will yield the best performance when compared to the existing systems. Thank you.